Once you have a database, you need to actually talk to it. How? Let me explain. A common language used to do this is called SQL, often called SQL, and stands for Structured Query Language. Most relational data management tools, also known as RDBMS tools, support NC-SQL. That's the version of SQL defined by the American National Standards Institute, which is generally considered to be the standard, or minimum most widely supported set of commands for the SQL language. Though many tools offer their own flavor or version of the language that extends NC-SQL to add features specific to that DBMS, the two examples of these are T-SQL or Transact SQL, used by Microsoft SQL, and MySQL, an open source DBMS that includes a few other useful features on top of the SQL standard. SQL allows us to write statements which the DBMS interprets, and that is how we interact with data in the database from apps or even within the DBMS itself. In this role of interacting with data, SQL is called a data manipulation language, or DML. SQL also offers features to manage the database itself by creating and modifying tables and controlling access to tables. In these roles, SQL acts as a DDL, or a data definition language, and a DCL, or a data control language. We will see more about SQL's capabilities as a DDL and the DML in particular later on. It's likely you'll need to read and write SQL at some point. So let's take a few minutes to explore this foundational language, and we'll get into more details in the near future. Don't worry about the specifics of statements at this point though. A SQL statement is composed of clauses which can contain expressions and predicates. A clause will include a keyword specifying some action to take and something to act on or use. Expressions and predicates set parameters in which to operate. Statements can be written inside of software that works directly with the database, like SQL Server Management Studio, or they can be incorporated directly into program code in order to allow an app to access data. To ask for data from a database, we will ask for the fields we want the data from, and we will specify the tables that contain the information. We might also specify how to display, sort, or associate the information. And in return, we will get matching records or fields from records which match our criteria. This statement, for example, will show us the first name and last name of customers with specific birth date. And this one will return us a list of customers' names and birthday dates sorted chronologically by birthday. In the first example, we have two clauses. In the first clause, there are field names, and in the second clause, there is the name of the table to read the fields from. In the second example, we have three clauses. The first asks the first name, last name, and birthday fields. The second clause tells the database to use records from the customer's table. And the third is telling the database which field we will use to sort records we get back. Because we are asking for information from the database or asking for the database to do something, these statements are called queries. In SQL, it's common to see the keywords written in uppercase, though it's not strictly necessary. It can help with readability, though. So in this movie, I will keep the keywords uppercase, putting data into a database, retrieving data from a database, changing records, and removing records are typically things we'll do with an SQL query of some sort. And even if you're working at a higher level, like writing an app that interacts with a database, eventually, whatever you're doing with your data will get translated into an SQL query somewhere along the line. These activities, create, read, update, and delete, are called CRUD, and they are the basis of interacting with data. SQL allows us to write out what we want, and the DBMS returns what we have asked for, or otherwise acts on the data in the database for us. We will revisit SQL in details later on in the near future.